Welcome to 9.07 tree diagrams. Now this video is a little different because you will not be receiving the information in class, so it's really important that wherever I am reminding you to write the information in your notes that you do so. And you should have in front of you the worksheet that you were given in class today, so you can complete that as we do the video. Okay, so we've done all this talking about probability, and sometimes it can get confusing to see all of the different probabilities that you have in a problem. So that's where tree diagrams come in. So tree diagrams are a way of displaying all of the probabilities. Okay, so tree diagrams help us to display the probabilities. And you'll see on your piece of paper that they're covered. Your paper is covered in all kinds of what are called tree diagrams. So we have what a probability is, what the situation is, and then these are called branches. So each one of these are called a branch. The fact that they're called branches is not what is important, but I want you to see that it looks like a tree. Okay, so we have Samantha's plans for Saturday, and then we have these two possibilities. Okay, so forget what you see over on this side right now. So Samantha has plans for Saturday. She is either going shopping to the mall or she is going to her cousin's house. Okay, so the first thing we need to do is we need to use the complement. Remember, the complement means you either do something or you don't do something. So in this case, she is either going shopping or she is going to her cousin's house. Okay, so the display here is 37%, which is 0.37. Doesn't matter which way you write it, but eventually we're going to need the decimal. So the probability if she goes to her cousin's house is 0.63 because she is either going one or the other, and these two probabilities have to add up to 1. Okay, so then we follow along the branches from here. If she goes shopping at the mall, she's doing one of these three things. She's either buying a dress at full price, she's buying a dress on sale, or she does not buy a dress. Okay, she's doing one of those. Okay, so if we know that buying the dress on sale is 20% or 0.2, does not buy a dress is 21%, then the probability she is going to buy a dress at full price is 0.59. Because I add these three together and they have to add up to 1. Okay, so baking a cake, 55%, so 0.55. And if she watches a movie, or she's going to watch a movie, so that's 0.45. And again, you can write them as percentages, but we need them this way. Okay, so how you use the branches is we're multiplying them together. It ends up being an and type of situation because she's going to, let's do this for example, she has plans for Saturday, she's going shopping at the mall, and she's buying a dress at full price. So we follow the branch and we multiply these two together, for example, if we were doing that. Okay, let's say, let's see, fill in all the missing probabilities. Okay, so we've done that already. What is the probability that Samantha goes shopping? Oh, look at that. I was one step ahead. I forgot that that's what it was. What is the probability that she goes to the mall and buys a dress at full price? So we have 0.37 times 0.59. And just so we recognize the notation, so it's the probability of going to the mall and buying a dress at full price. So we'll make that FP for full price. And that's equal to the probability of going to the mall and, or we can multiply it together, multiply by the probability of buying the dress at full price. And that's these two probabilities right here. Okay, so we multiply them together and we get 0.22 or 22%. We can write a probability either way. Okay, so now what is the probability that she goes to her cousin's house and watches a movie? So the probability of going to her cousin's house and watching a movie. So it's the probability of going to her cousin's house is right here, 0.63 times watching a movie, right here, 0.45. Those two multiplied together is 0.28 or 28%. Okay, so tree diagram helps us set up all the different possibilities, and then we can just multiply along the tree. Okay, so here's another one. This one is on your paper. So the first thing I want you to do is fill in all the probabilities. So pause the video, fill in all the probabilities, and I will write them in here for you. Okay, there are your answers. Probability that Jay drives to San Francisco and parks in a parking garage. So, driving to San Francisco, parking in a parking garage. If you want, you could change them all to decimals, but I know I can change it to a decimal when I get over here. So the probability of going to San Francisco and parking in a parking garage is 0.1 times 0.99, which is 0.099 or 9.9%. Okay. All right, probability that Jay takes Bart to San Francisco and buses from Bart to the train station and buses from Bart station to his destination. Okay, he takes Bart and then buses from Bart to his train station. So 0.9 times 0.68, 0.612. 61.2, oops, 61.2. Either way. Okay? All right, next example. All right, so pause the video and do this whole problem, and then I will be back and put the answers on. Okay, there you go. You would multiply these out and come up with the answer, but it's important that we have the right numbers here. Okay, so the next one we have a little bit more work to do because we're going to be solving for what is missing. Okay, so in this one, Jack and Jill's anniversary is coming up. Jack is planning a surprise party. Probability that Jack takes Jill out to dinner and then pays for the whole dinner is 60%. What is the probability that Jack takes Jill out to dinner? Okay, so probability that he takes her out to dinner and pays for the whole dinner. So the probability of going out to dinner, okay, so we'll put dinner and pays is 60%. Okay, so what is the probability that Jack takes Jill out to dinner? So we're looking for this one. This is the unknown. Okay, and we know that this probability, because we can subtract 0.15 from 1, is 0.85. So we know this one. We have to find this one. But we know what this branch is. We know that we have multiplied these together and we have 0.6. Okay, so we know that it's probability that he takes her out to dinner and he pays for it is equal to the probability of going out to dinner times the probability of paying. Okay, so now we just fill in the blanks. We know that one is 0.6. We don't know this. The probability of taking her out to dinner is what we don't know. And then the probability of paying is 0.85. This probability that he takes her out to dinner is the unknown, and that's what we're going to solve for. Okay, so we divide both sides by 0.85. So 0.6 divided by 0.85 is equal to the probability that he takes her out to dinner. And when we use our calculator, we get that information, and we get that it's 0.71. So this is 0.71. Okay, so then the next question is, what's the probability that Jack gives Jill a present? Well, we know that these two probabilities add up to 1. So therefore, we subtract. So 1 minus 0.71 is going to be the probability that he gives her a present. Okay, so that is 0.29 is the unknown of there as well. Okay, all right, so on your paper, number 1, Kelly's making a cake for her mom's birthday. Probability that Kelly makes a vanilla cake with red frosting is 15%. Okay, so probability makes a vanilla cake with red frosting is 15%. What is the probability that Kelly uses chocolate batter? Okay, so we're right here. We're this one and this one. So now what is the probability that she uses chocolate batter? Well, if we can solve this one, we can solve this because we can subtract from 1. So let's just go through and go through the process here. So this probability is equal to the probability of vanilla times the probability of red. Okay, I'm going to run out of room. Go down this way. Okay, so the probability of vanilla and red is 0.15. The probability that she used red frosting is 0.25. So we're going to divide them. So the probability that she uses vanilla is 0.6. So here's the vanilla batter with 0.6. So to use the chocolate batter, we do 1 minus 0.6, and we get that the chocolate batter is 0.4. Okay. All right, and then the next question is asking us what's the probability that Kelly uses vanilla batter? Well, we already did that, 0.6. Goes right there. Okay. All right, so now you're going to do number 2. So pause the video, do number 2, and then start it when you're done, and I will fill in the answers. Okay. So now let's talk about filling in a tree diagram based on this scenario. Okay. So we have a Mount Eden baseball team, and their team leads at halftime 60% of the time in a season. The team wins 80% of the time when they have the halftime lead, but only 10% of the time when they do not. Make a tree diagram. Okay, so we have drawn the boxes for you. So basketball team leads 60%, or when they lead at halftime, basketball team leads at halftime in 60% of the games in a season. So this is 0.6. Does not lead at halftime, has to be the complement of that. Okay. So then we know that the team wins 80% of the time when they have the halftime lead. So when they're leading, they win 80% of the time. That means they lose 20% of the time. Okay? They only win 10% of the time when they do not have the lead. So when they do not have the lead, they win 10% of the time. So this is 0.9. So what I want you to do now is we're going to multiply all of these branches to come up with what our probabilities are for each of the scenarios. So that's the other benefit of drawing a tree diagram. So all the way here, 0.6 times 0.8 is 0.48. 0.6 times 0.2 is 0.12. So 0.4 times 0.1 is 0.04. And then this one is 0.36. So, for example, 0.04 is the probability of does not lead at halftime and then wins. So these are all of the probabilities of all of the scenarios. So now we can answer the question very easily. What is the probability that the team wins a particular game during the season? Well, winning occurs here, and winning occurs here. So they win either when they lead at halftime and then they win, right? Or they are not leading at halftime and then they win. 0.04. So 0.52 is the answer to that probability. Okay, I think I have one more example. So one more you try, I'll show you the answers, and then the rest are on your own. Okay? So pause the video, answer this question, and then come back and check your answers. Okay, how'd you do? Okay, so we read the question, 55% chance of winning the match when she serves and a 47% if her opponent serves. Okay, so here's winning, and here's she's winning. Okay, and then we know that she's got a 50% chance of serving the match, and then we fill in all of the branches, and then we multiply to get these numbers here. Probability that she wins is right here or right here. Okay, all right. Finish the rest of the problems for your homework and come back and watch the video if you get stuck.